University of Tokyo.
Yep.
And currently I'm a PhD student, and I'm from Asami Kawahara Laboratory. And basically my research concentrated focus is on wireless power transmission and energy harvesting.
Okay, thank you so much. Yourself?
Yes, my name is Kwan. I'm from Vietnam. Actually, I'm the same laboratory with Weiwei, and currently I'm a master student. My research mainly is using this kind of technology for creating general ubiquitous interface, something like touch sensor using this kind of printing some pattern.
Excellent. Please tell me about your sensor. I understand it's for the agricultural application. Right?
Yes, definitely. Actually, this project is a kind of cooperative project and operated together with 3 universities: the University of Tokyo, the Georgia Tech, and the University of Georgia. And this project has already begun in an American cornfield called maize. Yes, it has already been deployed over there and testing. So this is current procedure. And actually this is basically the main part of the sensor we use here. And as you can see here, we basically use inkjet printer, which is commercially in our daily life. And we use conductive ink also commercially, and we bought it from Mitsubishi as a fabricator. And we print this ink, and we design a pattern, of course, and then we print the ink on this kind of paper, and to form different patterns with different features we desire. And for example, this is the main part of the sensor we call SenSprout, and it consists of 3 parts. The bottom part is used to sense the humidity, the moisture in the soil, and to see how wet the soil is, to determine how much water we should give to the plant.
Okay.
And for this part, it is for sensing the humidity and the moisture in the air, and even from the drop of the water from the leaves. And for this part is used for energy harvesting, and we use one to collect the power from the electromagnetic wave in our air to supply power to the microcontrol circuit.
So you're harvesting radio frequency
yes,
energy.
Actually it's 2.45 gigahertz.
All right.
Yes, actually. And I don't know if you can see here clearly, and we have a picture here.
It's a microcontroller.
Yes, it's a microcontroller, and integrated together with a 5-step charge pump used as a rectifier. And use this rectifier, we can rectify this kind of 2.45 gigahertz AC to the DC and supply power to the microcontroller integrated together in this case.
And what's the transmitter's radio frequency? It's the same 2.4?
Yes. It's also 2.45 gigahertz.
And would you use the same antenna to transmit the signal?
Actually, it depends on situation. For example, in this video, we are using 950, which is RF reader.
Yes.
Okay, I'll download it from the YouTube.
I can show it, okay? So here you can see, here's this is RF reader. Here is a frequency here.
Yes.
You can see if we put here, is to receive the energy from here to the antenna.
Yes.
And depending on the frequency, we will make a different pattern for the antenna. Here, if we try and put it in very wet soil, you will see here the sensor, this part.
Yes.
Whereas we go up, you can see. Here, yes. And here is the leaf. And if we put some water, you can see here, put some water on the leaf. Yeah, and this one is also go up.
Okay, very interesting.
Yes, as I mentioned, we make this interface.
Yeah, so one more thing is the duty cycle. If you can see, we have some kind of device control here to decide how long the system is going to sleep and wake up, depending on how much energy it can harvest.
Yes.
Okay. So you are still doing this research.
Yes.
What are the challenges you are trying to solve? You are thinking of any improvements to this sensor?
Yes, actually, the first one is we are trying to find out a better pattern. Pattern including the design of the pattern, and also include the material. We are use to fabricate, to print all these papers. Even a material about both the ink and the substrate, to find the material for us to have the best performance of both the sensor antenna here, capacitive sensors, and even the antenna here we use to collect power with the energy harvesting.
All right.
Yes. And also, actually, this project is one project, and we try to show people with inspiration that we can use this kind of inkjet printing to do the faster prototyping in both our research and in our daily life. Recently, the 3D printer is really hot topic, and I think it has the same function as...
Oh, it's really cool.
Yeah.
Well, thank you very much.
Thank you very much.
Thank you.
Thank you.